Hello students. In our DME class, we were discussing about sliding contact bearings. In the previous lecture, we have covered one numerical. That numerical was very important. I hope you have practiced this numerical so that you can continue with the other numericals. So let's discuss this numerical. The load on the journal bearing is 150 kilonewton. Two turbine shaft of 300 mm diameter running at 1800 rpm. Determine the following. First, length of the bearing if the allowable bearing pressure is 1.6 Newton per square mm, and second, amount of heat to be removed by the lubricant per minute if the bearing temperature is 60 degrees C, and viscosity of oil at 60 degrees C is 0.02 kg per meter second, and bearing clearance is 0.25 mm. So this is the statement, and we have to, first of all, we have to write what is given to you. In the statement, load on the bearing, that is W 150 kilonewton. So we will write W as 150 kilonewton. We convert it into Newton. Then diameter of the shaft, or we can say journal, 300 mm. So diameter D is 300, or we can say 0.3 meter. RPM is 1800. So we will write N is equal to 1800 RPM. Determine the following. Length of the bearing if allowable bearing pressure is 1.6. So bearing pressure is given to you 1.6, and you have to find length of the bearing. So how we will calculate the length of the bearing? We will apply the formula for pressure. Pressure is equal to load upon area. Pressure is 1.6, load is 150 kilonewton, area is length into diameter. Length you don't know, diameter is 300. So 300 into L will be your area, and from this equation we will find the length of the bearing, that is 312.5 mm. In the second point, you have to calculate amount of heat to be removed by the lubricant per minute if the bearing temperature is 60 degrees C. So we have given viscosity 0.02 kg per meter second, and bearing clearance C is given as 0.25, and we have to find amount of heat to be removed. So amount of heat to be removed will be equal to the amount of heat that is generated in the bearing. So amount of heat to be removed will be amount of heat generated, Qg mu Wv. So you have to find first mu, coefficient of friction, and its formula is this. Put the values of Z 0.02, N RPM, P pressure, T diameter, C clearance, and K is leakage factor, which is always 0.002. Find mu, that is 0.011. Then you have to find velocity, pi dn upon 60. Put the values, and it is 28.3 meter per second. So you have to find heat generator, that is mu Wv. Put the value of mu W and velocity, and this is your answer, 46,695 joule per second, or we can say watt, and then you can convert it into kilowatt. So this is your numerical. We will try another numerical as well. A full journal bearing of 50 mm diameter and 100 mm long has a bearing pressure of 1.4. Speed of the journal is 900, and ratio of journal diameter to diametral clearance is 1000. So we will write given data. So first of all, diameter of the journal, that is D is equal to 50 mm given to us. Length 100 mm given, and we are converting it into meter as well. Bearing pressure is 1.4, so we will write 1.4 pressure. Speed of the journal 900 rpm. So N is 900 rpm. And ratio of journal diameter to clearance is 1000. So this ratio D by C is 1000. Bearing is lubricated with oil whose viscosity at operating temperature of 75 degrees C may be taken as 0.011. So the viscosity is 0.011 and operating temperature TO, that is 75 degrees C. Room temperature is 35, means air temperature, ambient air 35 degrees C. Amount of artificial cooling required, that you have to find. Mass of the lubricating oil required if the difference between outlet and inlet temperature of oil is 10 degrees C. So temperature rise is 10 degrees C and specific heat of the oil is 1850 given to us. So S is 1850. So amount, assume dissipation coefficient 280, that we will see. So first of all, you have to find amount of artificial cooling required. And how will you calculate amount of artificial cooling required? It will be equal to the amount of heat generated minus amount of heat dissipated. So first of all, you will find amount of heat generated, that is Qg. As we have done in the previous numerical, Qg is equal to mu Wv. So mu is, we will find from this formula. This is the relation for mu. Put the values of Z and P, D by C and K, and you will get mu. Then W, you need to find pressure into area. From there, you will find W 7000 Newton and velocity pi dn by 60. Put the values of these three and you will get heat generated. Now you have to find heat dissipated. Its formula is Ca Tb minus Ta. Tb is bearing temperature. Ta is ambient air temperature. C is heat dissipation coefficient. You have to assume or you may be given in the question. A is the area, that is length into dia. So put the value of C, that is 280. Area, that is length into diameter. Length and diameter, we will put the value in meters because C is in meter square. Tb minus Ta. Tb minus Ta we can found from half of To minus Ta. This is the relation between the two temperatures. Tb minus Ta is half of To minus Ta. Put the value of To and Ta, you will get the value of Tb minus Ta. And you will put the value in this relation to find the heat dissipated, and it is 28 joule per second. So amount of cooling required will be heat generated minus heat dissipated, and it is 43.5. And now another thing we have to find is mass of lubricating oil required. So let M is the mass of lubricating oil required, and its relation is heat taken away by the oil, MST. M is mass, which you have to find, where S is specific heat of the oil, S 1850 given to us. So put the value 1850, and T is the temperature rise of the oil, and it is 10 degree given to us. So Qt is the amount of heat taken away by the oil. So this is the amount of heat which the oil has to take away. Since the heat generated at the bearing taken away by the lubricating oil, therefore equating heat generated to the heat taken away by the oil. So it is 71.5. So equate it with the 18500 m and you will get the mass of the oil, and the answer will be 0.23 kg per minute. So this completes your numericals and your sliding contact bearing. In the upcoming lectures, we will discuss rolling contact bearings. Okay guys, thank you.